Hi, everyone. We're going to talk about equivalent expressions involving fractions, radicals, and powers, or expressions with exponents. This is really key in calculus. You have to know this. It's your bread and butter. Because sometimes when you take derivatives and integrals of expressions or functions, it's important to rewrite them. So we're going to consider pairs of equivalent expressions together with relevant restrictions, including hidden restrictions. This is related to the important domain issue in section 1.1. Now, as far as domain or restriction issues go, what are the two things that you never ever do if you want to keep things real, if you want to keep it real? You never divide by what number, and you never take square roots, fourth roots, in general, even roots of what kinds of numbers or values. So, restriction issues. The restrictions guarantee that we never do the equivalent of dividing by 0, right? That includes doing things like this. If you see 0 to the negative 1, that's undefined. That's not real. That's no good either. So dividing by 0, that's a sin. Also, taking the even root of a negative value. Like if you take the square root of negative 1, that's a sin because that's not real. We need to keep it real. All right, I'm going to play some cover-up games here. It's like a politician. All right, gotta be careful though. All right. And don't confuse exponential form with exponential functions. Really, I might use the term power form when I'm using exponents. All right, here we go. Let's see if this works. All right. 1 over x. How can you rewrite that as a power of x? And what are the restrictions? Domain restrictions. 1 over x. Remember the laws of exponents? That's going to be x to the negative 1. If you forgot your laws of exponents, I'll pull up the laws of exponents. All right. Over here, remember? X to the negative 1 is 1 over x. It was related to number 7. X to the negative 1 is 1 over x. All right. Oh, and x cannot be 0. You never divide by 0. That's the restriction. But it's not hidden. It's evident. How about 1 over x squared? That's going to be x to the what? That's going to be, again, by this rule 7 here, 1 over x to the second is x to the negative 2. Again, x cannot be 0, because then we'd be dividing by 0. First two, not so bad. Oh yes, you're going to see guys like this in calculus. 1 over 7x to the negative 4/3. Write this as a constant times a power of x. A constant times a power of x. In fact, let's actually work it out. Let's work it out. All right. So we can split this up as 1/7 times 1 over x to the negative 4/3. So I'm breaking up that fraction into a product of two fractions. The coefficient is 1/7. Okay? So bear in mind, the 7 down here does not pop out as a 7. All right? If you have a 7 down there, the corresponding factor is 1/7. And that's the coefficient here, 1/7. See, the negative exponent here, it tricks people into thinking they can move up the 7. But the base for the negative 4/3 is x, not 7x. The negative exponent has nothing to do with the 7. All right? So our coefficient here is 1/7, not 7. All right. Okay. Now, the x to the negative 4/3, remember we had a rule over here, all right? X to the negative 4/3, okay? We're basically using rule 7 again, except n is a negative number this time. We can do this sort of popping or hopping rule, all right? So x to the negative 4/3, it's in the denominator. Okay, it is the denominator. It's certainly a factor of the denominator. That can pop out or pop up in the other part as x to the positive 4/3. That's really messy. X to the positive 4/3. Right. So we can think of this as 1/7 times x to the positive 4/3, which you could then move up to the numerator if you like. Okay, 1 times that is that, so you can move this up to the numerator. All right, bottom line. And also consider restrictions. Is a restriction on x? Bottom line. I think it's going to be 1/7 x to the 4/3. Well, looky here, 1/7 x to the 4/3. And again, if you wish, you can rewrite this as a single fraction, x to the 4/3, all over 7. That's also acceptable. Now, because of the negative exponent on x, if you have x to any negative exponent, then x cannot be 0. There's no way that's going to work out. Right. But then you might be wondering, well, would negative numbers work out? So you could consider 3 cases here. Let's consider 3 cases. The case where x is positive, the case where x is 0, and the case where x is negative. It's like an SAT test. All right. So let's think about it. If x is a positive value, do things work out? Well, there's no reason things shouldn't. We have a cube root here and a 4th power here. Okay, well, I guess I'll look over here, right? Okay, we have a cube root here and a 4th power here, all right? And we basically have those ideas down here, right? Okay, so we don't have any problems with positive values of x, but what about x equals 0? We have a problem right here. If you have x to a negative exponent, you're dead right there. Can x be negative? Well, basically, we're looking at this cube root issue, and we can take the cube root of a negative number. So positive values of x are okay. Negative values of x are okay. However, 0, that's not good. So positive, negative values of x are okay, but x equals 0, that's no good. That's the only restriction on the reals. So we're relating here fractional forms with exponential or power forms. Here we wrote the expression, we rewrote it as a constant coefficient times the power of x. And there was a hidden restriction. It's not evident in this final expression that 0 is still illegal for x. So we should include this hidden restriction. Okay. Hidden restriction, x cannot be 0. Next up, we're going to talk about radical forms more explicitly.